Hey guys, sorry I'm not there today, but I just wanted to take some time to go through your sedimentary rock, metamorphic rock, and rock cycle notes with you. If you need to pause the notes along the way, you're welcome to do that so that you can get everything written down. But we'll start with sedimentary rocks, or how do we classify sedimentary rocks? Okay, so to start off with, sedimentary rocks are a rock type that's formed from accumulation of sediment derived from pre-existing rocks and organic material. They form through a process called lithification. The word lithos comes from the word rock, and so lithification is just the building of a rock. And the way we classify sedimentary rocks includes several different options, kind of similar to the way we classify igneous rocks that we talked about yesterday. So we'll start with texture. So texture is basically the size, form, and orientation of the clasts, or what we call pieces in a rock. Clast just means pieces of a rock. It's the main factor in our identification of sedimentary rock. So let's look through some of that texture that we can have. A clastic rock is a rock that formed from fragments or pieces of other rocks and can be identified by size. So we can see the individual grains in the rock as well. And sometimes they're larger and sometimes they're smaller, just depending on the type of rock that you're looking at. But clastic, you can see those individual pieces. Another type of texture that we have is called crystalline, and this is a rock that forms from mineral grains that have fallen out of solution by evaporation. So this leaves behind gypsum or rock salt that we can see when water evaporates from a dissolved substance. Another type is called bioclastic. And I know we talked about how minerals have to be inorganic, but rocks don't necessarily have to. And so a bioclastic rock is a rock that forms from the remains of plants and animals, similar to coal being pressed down over thousands and millions of years to give us the fossil fuel that we use, and limestone as well. Limestone is formed from the remains of different plants and animals, the calcium carbonate that they leave behind. So this is just showing different types of rocks. This is called conglomerate, and you can see conglomerate is characterized by these rounded fragments that have smooth or edges. Another classification of sedimentary rock is called breccia, and breccia has more angular type of fragments that you can see the sharp edges on. The way that sedimentary rock forms is how the clasts of the sedimentary rock are held together. And so most sedimentary rock form under large bodies of water in a couple of different ways. So let's look at one way called cementation. It just means that small particles like clays, sands, or silts are glued together. And so this usually happens when water between the sediments dissolves and the remaining material holds those pieces or clasts together. And so that leaves behind, so we've got our cemented fragments that form a rock similar to this, that's limestone. We also can get sedimentary rocks formed by compaction. Compaction just means that the layers are sort of squished together because more sediment settles on top of them. And so we usually end up getting what we call a decrease in pore space, or spaces between those particles, and the sediments become more tightly packed. And so here's a couple of what compaction sort of looks like. So this would be like sandstone, where the mineral grains or the sand kind of cements together because of all the weight of the rock above it. Here's showing you another example of sandstone and magnified sandstone. So you can see all the little pieces kind of zoomed in and stuck together because they were compacted together. And finally, we can get sedimentary rocks that form from chemical action. This is formed when dissolved minerals form a crystalline mass of mineral crystals that are left behind after evaporating. And so here's just showing you the salt flats in Utah that are left behind that form crystals, or rock salt as well. And so we can get rock salt from, again, that dissolved material. There are some characteristics that are common to all sedimentary rock, and so that help us identify that sedimentary rock. And so we can see the layers, especially, that's some of the examples that we see. So they can form at or near Earth's surface where weathering can break down the rocks into pieces. So you can see here that an arch formed in the western part of the United States. We also get them forming in horizontal layers. And so that layering, straight line layering, often gives us an idea that it is sedimentary rock. You can see that in both these pictures. And finally, sedimentary rock is the only rock type that can contain fossils. And so we'll often see fossils that form in sedimentary rock. They're a little more gentle in how they form. If you think about igneous rock forming from magma or lava that's hardened, you're not going to see the remains of living creatures in them. When sedimentary rock forms just from the compaction or cementation of weathered particles, that's when we see fossils that form. So you also have this Earth Science Reference Table option to kind of look at the different types of rocks and see identifying features of them. And so you have this that you were given, a handout that you were given out yesterday. Now let's look into metamorphic rocks. So metamorphic rocks are where the parent rock has been altered because of increases in temperature and or pressure. And so we'll see changes because of that. The parent rock is the pre-existing rock from which metamorphic rocks are formed. And that can be anything from a sedimentary rock, an igneous rock, or another metamorphic rock, but they've undergone a change. That's what metamorphosis means. So they can be changed by heat, where the rock expands when heated, and so the atoms break apart and are able to move around. As the temperature decreases, the atoms join with other atoms to form different compounds, and you get a structural and chemical change in the minerals. We also can see metamorphic rock that forms from pressure. So under extreme pressure at great depths inside the earth, like when the plates are moving around, the atom bonds are broken and rearranged into a denser and more compact structure. And so just showing the pressure changes, how it presses down and it rearranges those atoms and you get different patterns. Okay, so how do we classify metamorphic rock? So we'll start out similar way that we classify igneous and sedimentary rock, by texture, so the general appearance of the rock. Things that you'll see in a metamorphic rock is foliation, so those minerals rearrange in flat layers because of extreme pressure. We also will see a type of foliation that's called banding, where that pressure separates those minerals, so you'll see a light layer, a dark layer, a light layer, a dark layer, and so on. And so that's one of the characteristics that you'll see in a metamorphic rock, especially when they're formed due to pressure. But sometimes you won't see, so here's showing slate. You can kind of see the different lines there that are formed within the different rock. And this is another rock called gneiss, and you can clearly see the light and dark banding. Sometimes those rocks will not have any layers, and so this usually happens when they've undergone extreme heat. And so we call those non-foliated rocks. So the minerals rearrange and change form, but don't form layers. And so here's showing an example of that. So that's showing a non-foliated quartzite and non-foliated marble. Grain size is another way that we identify metamorphic rocks or classify metamorphic rocks. So they can have medium grains. This rock is called schist, or very coarse grained. This is called metaconglomerate, and you can see those big, giant individual pieces of mineral. We also classify metamorphic rock by composition, or the minerals that make up the rock. This is calcite that forms into marble, and this was mica that forms into slate. How metamorphism happens, we have what's called regional metamorphism, where we'll have metamorphic rock that are formed over large areas due to temperature and pressure increases. Most of these rocks are formed under a mountain or deep inside the earth. Or we have contact metamorphism, where the pre-existing rock changes when heat from lava or magma change those minerals around. And so we look at contact metamorphism, where that lava or magma touches the rock and heats it up. And again, you have the same metamorphic rock identification on your reference page that you have that goes through the different characteristics of each of the different types of metamorphic rock. Okay, so let's look at the rock cycle. So the rock cycle just shows how rocks change from one form to another, undergoing different processes on Earth or in Earth. So it's a model used to show how the different rock types are interrelated and the processes that form them. Any rock can change into any other type of rock, and so any rock could contain materials that were once part of another rock. So we look at the different stages of the rock cycle. So an igneous rock can undergo weathering. Those sediments can then be transported, be deposited, and eventually stick together to form sedimentary rock. Sedimentary rock can undergo deep heat and pressure to form a metamorphic rock. Metamorphic rock can melt into magma, can crystallize and form an igneous rock. And all of these can also cross across the cycle. So igneous rock is formed from melting and solidification. Sedimentary rock is formed from fragments that are held together by cementation, compaction, or chemical action. And metamorphic rocks are formed from heat and or pressure. The driving forces of the rock cycle include things that will create uplift, where we're pushing rock up to the surface, weathering or the breakdown of rock into smaller pieces, erosion, the carrying of those pieces from one place to another, pressure from plate tectonic movement, and melting to form magma or lava to form our different types of plate movement. Okay, so this can happen in Earth's interior or because of issues from the sun that will create weathering issues. Gravity as well plays a role in the rock cycle. And so just looking at the rock cycle, you will see the different processes that can occur where any type of rock can form another type of rock, just undergoing different processes.